For this example, 4 different airlines, American, Delta, United, and US Airways, worked with the marketing research company to check their passenger satisfaction level. And what we're trying to find out is there a difference in the mean satisfaction level among the 4 airlines? And we're going to use a 0.01 significance level. Now I laid a lot out here. It's a little bit confusing looking, but once we get started and start going through this, it should be a little bit clearer. And the Anova table is what we generally use to evaluate our Anova. And you'll see here what I have are cell references. So this sums of square total cell is actually pointing to this cell, which also has the sums of square total highlighted in here. So this Anova table will start self-populating as we fill in some of these values. When we start an analysis of variance, the first thing we generally want to do is to find out the sums of square total. And the sums of square total formula is right here. Sums of square total is equal to the sum of x minus x bar sub g squared. So we're familiar with x. What's x bar sub g? Well, it tells us right here that it's the overall or grand mean. So what exactly is the grand mean? Well, we have each of our data sets here from each of the different airlines. Oh, you will also notice some of these formulas that are pretty simple I've left in here already, pre-populated, because we're just summing up the columns here. And then below that we have the count for each column of data. So those are in there. So all we have to do to calculate the grand mean is take the mean of all of our data elements. How do we do that? Easily. We just use our average formula and we select our first set of data. But now, before we select the next set of data, hold down the Control key, and now we can select each of the sets of data. Close it out with a parenthesis, hit enter, and we get 75.64 as our grand mean. Now, if we go back to our formula again, what we're going to do is we're going to sum up each observation minus the grand mean squared. So the first thing we're going to do is just simply take each observation and subtract from it the grand mean. But because we're going to copy the formula, we're going to hit the F4 key, and notice how we have the $Q, $12. That makes it a fixed reference. We want to make it a fixed reference so that we can copy it without it changing that cell reference there. Now, you'll notice here on the top, on the subject, in each column heading, I have x sub a minus x bar sub g. The x bar sub g is the grand mean. The x sub a is just referring to American. Here we have x sub d for Delta, x sub u for United, and x sub us for US Airways. So we can reduce a few of these. And now we can just copy the formula oops, that was too far. Let's just drag it this time. And so there we have our first calculation. Now the second step is, because the formula calls for it to be squared, we square the result. So all we have to do for this, we could use the power formula, but to keep it simple and clear what we're doing, we'll just multiply the cell by itself. Carry that all the way down, and there we have done our American Airways or American Airlines. Now we do that same function here for our delta, again, hitting F4, and again, dropping off some of these decimal places there. Same thing for United. One more. And finally for US Airways. Now each of these columns of the x minus x bar, or the grand mean squared, I've already put the column totals in, but all you have to do this is to equal sum, if you spell sum correctly, and select your data. You can just hit enter, or you can close out the parenthesis and hit enter, and it gives you your sum value for your x minus grand mean squared, which is what is our sums of square total. Now, just think about this for a second though. We want the sums of square for each observation minus the grand mean. So is this what we're looking for here? Well, it's what we're looking for, but only in part. We have to factor in each different airlines to get the sums of square total. So to calculate out our sums of square total, all we have to do is add up each of our column totals for the individual x minus grand mean squared. And there, our grand mean is 1,400. Our sums of square total is 1,485.09. So as you can see, now that we have the sums of square total value over here, it pre-populates or automatically populates the sums of square total value in our Anova table. Now that we have the sums of square total done, we move on to the sums of square error. And that formula is we sum up each individual observation minus x bar sub c. And in this case, x bar sub c is the sample mean for treatment C. That just happens to be how I copied, or where I copied the formula from. In our case, what we're doing, it's for each treatment or each grouping of data observations. In our case, they're by airline. So I have an x bar sub A for American, x bar sub D for Delta, and x bar for sub U for United, and x bar sub US for US Airways. And all this is simply the mean, or the average, using the Excel formula, for each of these different airlines data sets. And just be careful that you don't accidentally include the totals from the column in your calculation. You only want the data, the raw data. Okay, so now we have each of our column or our groupings means. And now, going back to our formula, what do? We sum up each observation minus the mean for that particular grouping or that airline, and then we square it. And if you notice, there's a little red triangle here. If we put our mouse over that cell, it pops up a note that I put in there. And all it's saying is that instead of doing two separate columns like I did over here, I combined the two columns, so we do the squaring right in the cell. How do we do this then? Okay, again, we go back and we take the original observation. Actually, let's start by doing this correctly and put the formula in, the equal sign in there. We're going to open up our parenthesis because remember we're going to be doing the x bar or x minus x sub a minus x bar for each calculation, and we're going to square it. So we're going to have two of the same things in there. So we take our x observation and we subtract from it our x bar sub a, and you'll notice that I did not change these up here. They all say C when they actually should be the same letters as we have for the particular airline. And we're squaring it, so we do this just the same thing again. And remember to hit F4 to make it a fixed reference. And there we have it, 45.56 for the first value. We can just copy that down. Now you should, well, we're not going to do that. Let's go ahead and do that for our delta. Here's our delta mean, fixed function. Okay, and there we have it, 10.24. Copy the formula down. Move on over to our United. Make sure it's fixed reference. Okay, we have 8.16. Copy that down. And finally, the same thing goes for our US. Or excuse me, US Airways. And we get a value of 1. And now we have all of our x minus x bar values. Or excuse me, x minus x bar for each of the particular treatments or different columns or different groupings, however you want to refer to it. To calculate the actual sums of square error, let's go back to our formula and see what we do. Okay, we did this portion right in here. Now we just need to sum them all up. Similar to the way that we did for the sums of square total, only now we take the different column. And here we have American Airlines plus Delta plus United plus US Airways. And we get our sums of square total showing up, or excuse me, sums of square error of 594.41, and it also populates our sums of square error column or cell in our Anova table. Let's backtrack for just a second here. I mentioned that we're going to use a 0.01 significance level, but we have to figure out what our critical value is. Now I already put it in here, but how do we calculate that? Well, we go to our table in the back of the book for the F-test, Appendix B4, and we want to use the 0.01 significance level, and that's on the second page, and we need to know the degrees of freedom for the numerator and the degrees of freedom for the denominator. If we look at over here at our trusty little printout that I copied into the spreadsheet, we see that our F-test is MST over MSE, which is right here, these two values, and they correlate to our, or are related to our degrees of freedom listing here. So what's K minus 1 mean? That's just K minus 1 is equal to the number of groups or treatments, as they're frequently called by minus 1. So we have 4 different airlines. Those are the number of groups or treatments that we have. Minus 1 is equal to 3. And then the denominator degrees of freedom is N minus K. N minus K is the total number of observation minus the number of groups that we have. So we have a total number of 22 observations. If you wanted to check that, you can do that. You can just also count all these up here, and you'll see that they sum up to 22. Minus 4, because we have 4 different groups or 4 different treatments. So that means our denominator degrees of freedom are 18. So we move across in our across the top of the page for our 0.01 significance level B4 appendix to 3 degrees of freedom in the numerator, and then we move down to the row with 18 degrees of freedom for the denominator. And at that intersection we have a value of 5.09, which is our critical value. So then what is our decision rule then? Well, the decision rule is to reject the null hypothesis if the computed value of the F exceeds 5.09. And I just put the critical value over here to make it nice and clear, because it's going to be, this is where our test statistic is going to appear once we get all of our calculations done in here. Going back to our problem, we notice that we have in our Anova table the sums of square total and the sums of square error. Well, we know that all of the variance is made up by the sums of square treatment or groups and the sums of square error to give us our sums of square total. So we could just simply subtract the sums of square error from our sums of square total. And I have a green block over here already set up for that, because it's right near where our sums of square total is and our sums of square error. And you'll see it populates 890.68 right into our sums of square treatment value over here. So now we need to find out what is our mean square value for treatments and our mean square error values right here and here. Now the table is laid out nicely. You can look over here to where we have our cheat sheet, and we can see that the mean square total, or excuse me, the mean square treatment is the sums of square for treatment divided by K minus 1. Well, what's K minus 1? Well, that's just our degrees of freedom. So our mean square for treatment is our sums of square for treatment divided by our degrees of freedom. So all we have to do is calculate that right here in our cell reference, and we get 296.89. And we can do the same thing over here. We look at our formula, and its sums of square error is equal to, or excuse me, mean square error is equal to sums of square error divided by n minus k, which happen to be our degrees of freedom. So it's the same formula essentially as what's above for sums of square treatment. And we can just copy the formula down. Let's just do that. And we get 33.02. And if you remember, an F test is the variance of one value divided by the variance of another. So all we're doing here for our F test or computed statistic is to divide our mean square for treatments or for groups, whatever way you want to call it, and divide it by our mean square error. And we get 8.99 as our value. And we find that 8.99 as our test statistic is greater than our F critical value. So what does that mean? Well, the sample statistic we computed for F is 8.99, which is greater than the critical value of 5.09. So we reject the null hypothesis, and we conclude that the population means are not all equal. The mean scores are not the same for the 4 airlines, and at this point we can only conclude that there is a difference in the treatment means. We cannot determine which treatment groups differ or how many treatment groups differ.